Water is leaking from a hole at the bottom of a large tank. The volume of water in the tank at time t hours is V meters cubed. The rate of decrease of V is directly proportional to V cubed. Write down a differential equation satisfied by V. Given that V is 60 when t is 0, show that V squared is 3600 over AT plus 1, where A is a constant. When t is 2, the volume of water in the tank is 50 meters cubed. Find the value of t when the volume of the water in the tank is 27 meters cubed. Give your answer correct to 1 decimal place. Okay, so let's have a look at it here then. Here's a summary. So write down the differential equation is the first thing. The rate of decrease of V is directly proportional to V cubed. So here, rate of decrease of V, dV dt is the rate of increase, so there's the rate of decrease is minus dV dt, is proportional to V cubed, isn't it? So that implies then, we'll move the minus over, dV dt is equal to minus kV cubed. So, separating the variables and integrating now. And integrating. Gives. So let's have a look then. Okay, part B this is. V is 60 when t equals 0, isn't it? So B. So we've got dV, leave that as is. Leave the minus k as is and move the dt up to be with it. And then move the v cubed from times on that side down to divide on the other. This is v to the minus 3, so it integrates to v to the minus 2 over minus 2. This is a constant, so it integrates to minus constant times the time plus a constant of integration, which I'm going to call c dashed at the moment. The reason being is I'm going to run a minus through now, so this is 1 over v squared times 2, if I bring the v down, is equal to, and I've dropped the minus this side, and I drop the minus this side. And if I write c instead of c dashed. Okay, so let's invert this then. So 2v squared is now equal to, invert this fraction, 1 over kt plus c. And that tells us then that v squared is equal to, move the 2 from times down to divide, over 2kt plus 2c. Okay, now the initial condition for part B. V is 60 when t is 0. V equals 60, t equals 0, gives, so 60 squared is 3600. Is equal to 1 over, and it's just the 2c, isn't it? So that tells us then, move the 2c up this side, is equal to, and move the 3600 down at the same time. So, v squared then, put it back in, is equal to 1 over 2kt plus 2c, which is 1 over 3600. Multiplied by 3600 top and bottom of this fraction. On the top we'll have 3600. Here we'll have 7200, won't we? Lots of kt plus 1. And now let A equal 7200k gives, well, v squared will equal 3600 over AT plus 1, which is what we wanted for part B, which is here. When t is 2, v is 50. T equals 2, this is part C now. T equals 2, v equals 50. gives V is 50, 2500 is 50 squared, is equal to 3600 over 2a plus 1, because t is 2. Move the 2a plus 1 up on this side to times. Leave the 3600 as is, and move the 2500 down from times down to divide. So that tells us then that 2a is equal to 36 over 25 minus 1, which is 25 over 25. 36 take 25 is 11 over 25, so I've written it down straight away. A equals 11 over 50. So there's A. And now what does it finally ask for then? Find T when V is 27 meters cubed to 1 dp. So A is 11 over 50, so V when the volume, find T when the volume equals 27 meters cubed. So put that into this. 27 squared is equal to 3600 over A, which is 11 over 50. That's equal to 22 over 100, which equals 0.22. But it's 0.22 t plus 1. So now we can then move this 0.22 t plus 1 equals 3600 over the 27 squared. So what we did there was we moved these terms up here, we moved the 27 down here, and now we can find out. I'm just going to move this up a bit because I'm running out of room. So therefore t equals then, I'm going to do quite a few things here. I'm going to move the 1 over, so it's 3600 over 27 squared minus 1 in a bracket, and that's 0.22 t in my mind's eye, and then move the 0.22 down from times to divide. And we can tap that in the calculator now. Okay, so we got 3600 divided by 27 squared minus 1 equals, and then divide by 0.22 equals decimal 17.9 to 1 dp. Seconds, 1 decimal place.